So, don't you just love technology? Because apparently, this video, just the last video, which was part 2, which is really this same video, just decided to just stop recording on me. So, again, we're just continuing right where we left off. Yeah, technology, such a wonderful thing, lovely. Just gotta love it. But anyway, we were saying that we could split this up into 2 separate fractions, and and again, I was going to show you how to simplify those fractions there. So for those who don't really remember simplifying fractions, again, I told you I'd kind of give you a little reminder about how you simplify fractions here. Really, guys, the part that you're simplifying here in both of these fractions is technically 2 over 4. And again, the only difference is that one of them just so happens to be, outright negative. The one that's on the left, of course, is negative. But again, remember that 2 over 4 is the same thing as having 1 times 2 and 2 times 2. Right? So 2 is 1 times 2, and 4 at the bottom, that's the same thing as 2 times 2. I don't know how much you remember about rational expressions, or simplifying rational expressions, which are expressions that can be written as fractions. But again, whenever you're trying to simplify rational expressions like this, you can cancel out those common factors that are at both the top and the bottom. In other words, like this 2 over 2 here. So like the 2 over 2 will cancel out here. Because you got the same factor at the top as you do at the bottom, so they can cancel each other out. And we simplify this fraction 2 over 4, and now because those common factors at the top and bottom have canceled out, this is simplified to 1/2. Just a quick little reminder for those who don't have a calculator, who may not have a calculator that can simplify that fraction for you. Just a little reminder for you, because this is technically elementary school stuff. Alright, so again, we simplify these fractions. This is negative 1/2 here, and I'm sure most of us already remember that 2/4 is the same thing as 1/2. But anyway, so that's negative 1/2. That simplifies to, and technically, guys, the 2 over 4 here is the part that simplifies. That square root, that stays the same. But the 2 over 4, that fraction does simplify to 1/2. Now, that one, guys, as a coefficient, 1 as a coefficient of the radical, that 1 does not have to be written at all, because again, it's the same thing as 1 times the square root of 2. At the top, that's the same thing as 1 times the square root of 2. And if you're multiplying 1 times something, then that's just whatever, that's just this number. You don't have to write the 1 if you're doing 1 times something. 1 times 8 is just 8. So 1 times the square root of 2 is just square root of 2. So this here would be simplified like this. And this would be our final answer here. And so you could either write it like this, as 2 separate fractions, or guys, and again, I know I told you that you should split that into 2 separate fractions, but I just wanted to show you that there will be some problems where you will literally, where the answer will be split into 2 separate fractions, though. And so I did want to show you that here. But again, you could either write your answer like this, in this particular case, or you could put it back together as one single fraction. Same way that we split it into 2 separate fractions, we could put this now back together as one single fraction. And so at the bottom, if it was a single fraction, you still just have the same denominator, 2. So at the top you'd have -1, and you'd have plus or minus the square root of 2. And so you could write your answer either like that or like this, okay, in one or the other form. So let's say we were dealing with this example here, example 3. And so what we want to do is let's go ahead on and let's make sure that our equation is set equal to 0, and also let's make sure that we've got it in standard form while it's set equal to 0. So to get this set equal to 0, let's do some inverse operations and let's get some things to cancel out. Let's move these terms here on the right side, the x squared and the -4. Let's move those to the left side. So we're going to use the inverse operation of subtracting the x squared here to get that to cancel. Boom. And we've got 3x squared. Okay, and we've got to subtract x on both sides. 3x squared minus x squared gives you 2x squared. Okay, and you still got the plus 3x plus 1, and it's equal to -4. And then here we've got to, or we should, add 4 to both sides. To that way we're going to get all of the terms on the same side of the equal sign, and we're going to get 0 on the other side of the equal sign. So these cancel out, and that leaves us with, leaves us with 0 on the right side of the equal sign, right side of the equation. So on the left side we've got 2x squared plus 3x plus 5, and now our equation is in standard form and set equal to 0. And so from here we can identify a, b, and c. We can calculate our discriminant, calculate our negative b, which is the opposite of b, and we can calculate 2 times a, that 2a. So let's do these things. Let's go ahead on and identify a, b, and c. In this form, standard form, ax squared plus bx plus c. And the equation is equal to 0. A equals 2. B equals 3. And C equals 5. Okay, so our discriminant, b squared minus 4ac b, okay, that's 3 squared, really, that's 3 squared minus 4 times 2 times 5. Okay, so remember that we go ahead on and square the 3. That's 9. 3 squared is 9. And then you multiply -4 times 2 times 5. So -4 times 2 times 5 gives us -40. -40. So here the discriminant winds up being -40. Alright, so that's the discriminant, and we need to also calculate the negative b. Love technology. It's awesome when it's working right. It's real wonderful when it's working right. So the opposite of b. Alright, so the opposite of b, that is us taking the opposite sign of b, or in other words, us multiplying negative 1 times 3, which is negative 3. So negative b is negative 3, and again the discriminant was negative 40, and 2 times a, that 2a, 2 times 2 gives us 4 for 2a. A, 2 times 2, which is 4. So we've got all three parts there. So now that we know that what all three of these parts are, we need to go on and replace or substitute these parts that we just calculated into the quadratic formula. Alright, and so we'll replace those parts in the quadratic formula, and then if possible we'll simplify. So next, when we are plugging in or substituting those calculations into the quadratic formula, we're going to do that here. So again, the opposite of b, again it looks like negative b, but again the opposite of b, we had calculated that as negative 3 plus or minus, and we've got the square root of, and let's see, the discriminant, which is the part that's technically up under the square root, we calculated that as negative 40. And it's all over 2a. We calculated 2a to be 4. So this is all over 4. Okay, so we've got that. Now we need to see if we can simplify. The first thing here that we need to see if we can simplify, or that we know that we definitely can simplify, is the fact that we've got a square root of a negative number. And remember, anytime you're taking the square root of a negative number, remember what type of solutions you'll have. Here, because your discriminant is a negative number, negative 40, we are going to have two imaginary solutions. And so because of that, we need to simplify this and rewrite that radical as an imaginary number. So when we write this or rewrite this radical as an imaginary number, we're going to do it like this, because remember that the square root of negative 40 is the same thing as negative 1 times, it is the same thing as the square root of negative 1 times the square root of 40. So again, let's remember that. Square root of negative 40 can be rewritten like this. It's the square root of negative 1 times the square root of 40, which means that because the square root of negative 1 is the basic imaginary unit, I, That means we can rewrite this as I times the square root of 40. So this is negative 3 plus or minus I times the square root of 40 all over 4. Alright, and so from there, it's still possible. Actually, it's not. That's actually as far as we can go here. Oh, why did you guys let me do that? Did you guys really let me do that? You did. You let me do that. Well, you didn't let me do it, but I did that, and you didn't stop me. Of course, you couldn't because you're not here while I'm making this video, but it's okay. All right, so here, the discriminant. This discriminant was 9. It's supposed to be 9 minus 40, but again, what I wrote there was just minus 40. So our discriminant is 9 minus 40, which is negative 31. So again, I am changing this because it's supposed to be negative 31, right? Again, that was supposed to be 9 minus 40, which is negative 31. So again, this is supposed to be negative 31. And I'm sorry about writing over this like this, but again, that is negative 31. I'll try to erase some of it. Seriously? Are you really okay? So again, folks, remember, again, I had written that discriminant wrong. Again, that was supposed to be 9 minus 40, or 9 plus negative 40, which is negative 31. And so that number up under the square root is negative 31. When you rewrite it as an imaginary number, that's I times the square root of 31. This is your final answer here, and you can either leave it like this, or you can write it as two separate fractions. Again, I'm just going to leave it like this. Remember, one fraction would have at the top plus, and the other fraction, if you wrote it as two separate answers, the other fraction would just have a minus there. Because again, this symbol plus or minus indicates that there are two versions of the same answer, but there definitely are two answers. Okay, one of them is positive, the other one is minus. One of them is plus, one of them is minus. Okay. This answer here, for example 3, technically could be written as two separate fractions as well. Again, it could be written as two different answers, of course, by writing one answer with a plus, one answer with a minus. But it could also be written as having two fractions, sort of like how we had this one here, where you had two fractions. It could be written like that as well. But we're going to look at one more example here, and then we're going to call it for this video, because of the technology issue. This is wound up being part 3 of this video. So yeah. So let's say that we were looking at this example here: 6x minus 1 equals negative 9x. Again, remember, first thing we need to do is make sure that our equation is in standard form. make sure that it's set equal to 0 as well. So here, if we'll add 9x to both sides, then at 9x squared, add 9x squared to both sides. We wind up getting 9x squared plus 6x minus 1 equals 0. Because again, those 9x squareds cancels out. And so now that we've got it set equal to 0 and we've got it in standard form, let's identify our A, B, and C. Let's also calculate our discriminant, the opposite of B, and 2A. Alright, so what we got here, we're going to go ahead on and calculate this after we identify A, B, and C. So in this form, ax squared plus bx plus c equals 0. Again, a is the coefficient for x squared, so a is 9. B is the coefficient for x, so b is 6. And c is the constant term, -1. Alright, so let's go ahead on and do our discriminant, b squared minus 4ac. Alright, so b is 6. So that's 6 squared minus 4 times 9 times -1. Okay, so remember, we go ahead on and square that number. 6 squared is 36, and then we write out these three parts here together. Go ahead on and multiply -4 times 9 times -1. When we multiply these when we multiply these three numbers, what we get is positive 36. So this is 36 plus 36, which is 72. So our discriminant here is 72. Alright, so we've got our discriminant. Let's calculate the opposite of b. Negative b, or the opposite of b. Again, it's like we're multiplying -1 times that number, and so the opposite of b is -6. And then if we do 2a, multiplying 2 times a, 2 times that number, that's 2 times 9, which gives us 18. So we've got all three parts here, and now we just need to substitute those numbers into our quadratic formula. So let's go ahead and substitute those numbers into quadratic formula, and then from there, if we need to simplify, we can simplify it. Okay, so here, when we're plugging in these parts into the quadratic formula, let's go ahead on and do that. Remember, the quadratic formula is x equals, and we've got here x equals the opposite of b, so we calculated that to be -6, plus or minus the square root of the discriminant, which is 72. We calculated that, and it's all over 2 times a, which is 18. All over 18. So we have substituted those calculations, those parts into the quadratic formula, and now we need to see if we can simplify. And here we should be able to simplify this radical. We should be able to write that radical in its simplest radical form. So again, when we're simplifying or writing this radical in its simplest radical form, we take the radicand, that number up under the square root, that's 72, and we want to find factors of that number, find factors of 72, and you want to consider the factors of it that are perfect squares. And so you want to consider those factors that are perfect squares, and you want to use the pair of factors that has the largest perfect square in it to break that down. So again, just as a little reminder to you of simplifying or writing a radical in its simplest radical form, again, we identify those factors of 72, and we're particularly looking for factors of it that are perfect squares. I already see a perfect square. 36 is a perfect square. But I'm going to keep writing though, even though I don't think we're going to see any perfect square factors that are bigger than 36. We've got 3 times 24, we've got 4 times 18, we've got 6 times 12, we've got 8 times 9, and those are all of the factors. So the only perfect squares I see are 36, 4, and 9. Those factors there that are perfect squares, 36, 4, and 9. And again, we want to pick the pair, we want to pick that pair of factors that has the largest perfect square. So the pair of factors that has the largest perfect square, we can clearly see that that's the that's the pair that has 36, right? So we can clearly see that. And so we want to use that particular pair. And when we rewrite it, we want to write out the square root of 72 using those two factors. Okay, so again, we're going to rewrite that radical using both of those factors. Again, the square root of 72 is the same thing as, and remember when we did this, I said put that largest factor first. Put that largest perfect square factor first when you split it up. So it's the same thing. The square root of 72 is the same thing as the square root of 36 times the square root of 2. All right, and so. And now, of course, we simplify, and we actually take the square root and simplify that perfect square root. Square root of 36 is 6, right? So that is -6 plus or minus. Okay, and the square root of 36 is 6. So instead of writing the square root of 36 again, we're replacing it with its value, 6. Okay, and we still got the square root of 2, which can't really be simplified any further. And this is still all over 18. Alright, so we have simplified that radical. We've simplified that square root of 72. And actually, this fraction or this particular answer right here, it can be simplified even further. Yes, it can be simplified even further. When we're looking at these fractions, the -6 over 18, or even the 6 over 18. Remember, in one of the previous examples, I mentioned that you could split this up into 2 separate fractions, and that's just so that you could see again that you need to simplify both fractions, really, because you could leave it written as one fraction, and I'm probably going to come back and write it as one fraction. But again, so we've got the -6 over 18 there. That's that first -6. All right, and then we've got the plus or minus. If we wanted to split this into 2 separate fractions, we've got the 6 over 18, and remember there that 6 is multiplied times the square root of 2. But again, we see these fractions here, the 6/18s. Those fractions can be simplified. Again, whether you remember how to simplify it or not, it can be simplified. Remember, 6 has a common factor with 18. They both have a common factor of 3, right? So 6 is the same thing as 3 times 2. 18 is the same thing as 3 times 6. And actually, they have an even higher greater factor than that. Excuse me. Because 6 can be written as 6 times 1. Or 1 times 6, however you want to think of it, right? 6 times 1, 1 times 6. And again, so the common factors at both the top and the bottom cancel out. The common factor 6 at the top cancels out with the common factor 6 at the bottom. And we are left with the simplification, the simplified version of this fraction. So 6/18 is the same thing, or is equivalent to 1/3. And so we're going to, again, rewrite this fraction as -1/3. And we're also going to write this other one over here. Again, this is still plus or minus. We're going to write this other one here as 1/3. Now again, I'm going to erase this 1, because if we're multiplying 1 times anything, and we're multiplying 1 times that radical there, multiplying 1 times anything isn't going to change the value of that thing. So again, 1 times the square root of 2 is just going to be the square root of 2. So excuse me, but I'm going to go ahead on and erase this 1 here. Yeah, that just makes sense to me. So this is the same thing as 1/3 the square root of 2. But again, I'm not writing the 1 because it's not necessary to write that 1. Alright, so this can be written like this when we simplify those fractions. And again, if we just decide to put these two fractions back together again, they would have the same denominator, 3 still. And at the top you'd wind up having -1 plus or minus the square root of 2. Alright, so again, this is two versions of the same answer. It could be written like this, or it could be written like this here. Two versions of the same answer. Alright. So guys, that's it for this video. Again, this last problem had this solution here, where you could either write it as two separate fractions, or you could put it back together as just having one single fraction with the denominator or bottom as 3. And so that's it for this video. I do hope that this has been helpful to you with solving quadratic equations. And I may be sending you an announcement, possibly with another video that's just showing you how to write the answers in decimal form, because well, I might as well show you right here, right now. Sorry. Yeah, ain't no need splitting it up. I might as well go ahead and show you right now. Come on, right now. Alright, so let's say that you were asked to write the same answer that you just now got for this last example. Let's say that you were asked to write that in decimal form and to round to the nearest tenth. Hopefully you guys remember your decimal places, and that when you've got your decimal here, right, this place here, right next to the decimal on the right side is the tenths place, and so you will, when you round it to the nearest tenth, it will wind up looking like point something, just one number written there. where you only have the tenths place written. But guys, you will look at, of course, you will have to look at the very next number, and you'll use that number right beside it to determine whether or not you're going to round up or round down. If you don't remember how to round up or round down, folks, I don't really know what to tell you, to be honest with you. Of course, if that number is higher than 5, you round up, or if the number is 5 or higher, you round up, and if the number is 4 or lower, then you round down. So you look at this number, you round down if it's lower than 5, and you round up if it's 5 or higher. So again, when we want to write this in decimal form, we're going to have to actually calculate, and you're going to have to actually take the square root of this irrational number. You're going to have to take the square root of 2. And again, the square root of 2 can't be simplified to a simplest radical form, and it can't be, and it's not the square root of a perfect square. So the only other way to write this is if they ask you to write it in decimal form, then you'd have to completely go all out with it. All right, so remember that there are 2 answer versions for this, right? 2 different answer versions. One version is where you've got plus, and the other version is where you got minus, right? So you're going to do -1 plus the square root of 2, and that divided by, that's one sloppy divided by, it's okay. And that divided by 3 on one part of it, and then you'll do -1 minus square root of 2, and that divided by 3. So the square root of 2 is something like 1.41-ish, okay? 1.41-ish, okay? I don't have a calculator in front of me, but from memory, I pretty much remember that. And if I'm wrong, I'm wrong. But for this example's sake, the square root of 2 is going to be roughly 1.41. Now, this number goes on forever, and it does not repeat, but I'm stopping it at 1.41 here. Since they asked us to round it to the nearest tenth, I think I have enough digits. I've got enough digits written for us to round to the nearest tenth here. Alright, so again, the square root of 2 is something like, or somewhere around 1.41. So again, you've got to actually calculate the square root of 2 and write that as a decimal, and then simplify it like this. So you want to go ahead on and you want to simplify the top of the fraction. Simplify the numerator, the top of the fraction first. -1, oops, and I had already, give me a sec, I had already split this up. One of them, I had already split up. One of these was positive and the other one was negative, so we don't need that plus or minus symbol anymore, so I've already split that up. So this is plus, this one's minus, plus or minus. Okay, so we need to simplify the top of the fraction, simplify the numerator. -1 plus 1.4 gives you 0.41. So here you've got 0.41 divided by 3, and then over here, when you simplify the top of the fraction, you got -1 minus 1.41. That is -2.41. Again, I don't have a calculator in front of me, but I can tell you that when you divide 0.41 by 3, you get something close to 0.14 0.3, and you get something. It's close to 0.14. So again, I'm paraphrasing here, but I think I have enough. Digits. I'm gonna paraphrase with this next number, because again, but I have enough digits here to be able to round to the nearest tenth, though. So again, it's somewhere roughly around 0.13, okay, or 0.14. It's closer to 0.14 though. And then here, when you divide negative 2.41 divided by 3, you get something like 0.8. Actually, you get 0.83 repeating, where the 3 is repeating exactly. Okay, I don't even need a calculator to do all that right there. You get 0.83 where the 3 is repeating when you do that. And that's exactly, okay, yeah. And I ain't got to guesstimate what this is here. Alright, but we do have enough digits here to go ahead on and round to the nearest tenth in both cases. So these are your two number answers, but again, they want us to round to the nearest tenth. Again, the tenth place is that first place right after the decimal, and if we want to round to the nearest tenth, you're going to have to look at the number that is right beside it on the right side, and you will round up if that number is higher than, or if the number is 5 or higher. So, okay, neither one of these numbers here is 5 or higher. So we've got our tenth place, and we've got the number that's right beside it. Okay, yep, we got the number right beside it, and it's not higher than 5. So, and again, I'm going to erase those lines. So that means that we're rounding down. So, and when we round down, we just leave that number as is. Okay, the only time you change it is if you're rounding up. If you were rounding up here, this would be 0.2. If you were rounding up here, this would be 0.9. But when you're rounding down, you leave that number the same. So we're rounding down here on the tenth place, and this would be the answer if we were rounding down here to the nearest tenth place and writing it as a decimal. So that's it. I'm really done now. I didn't feel like having to make a video later just to show you something that's in your Khan Academy or Delta Math assignment, asking you to write your answer as a decimal. So I do hope that this video has been helpful to you. Honestly, I don't even know how long this is. There are 3 parts. They're probably really long, and I apologize if they are. However, it should be enough to help you, because I have not spared anything in explaining and writing out the explanations on how to do these problems. So I really do hope that this has helped you. That's all, folks. All 3 parts.